focus on what we've been doing here at the Swiss Ornithological Institute for the last 15 years or so. We've been trying to map migration of small land birds. I want to put it into a perspective of climate change. So what does it mean what we're doing at the moment, and how that data set that we're collecting can also contribute for future when we're faced with climate change. And looking at the climate change, we all know that the temperatures are rising over the last decades and hundreds of years. So here is going to be an animation of about 150 years of temperature changes across different countries. You can see that different continents are ranked together. So wherever you are in the world, you can find your country. So Europe is here, that's Americas, Africa is here, and Asia is here. So if you're interested, you can see how the temperature has changed in your specific country where you live or work over the last years. So let's just run the animation, and you will notice towards the end of the 20th century and the beginning of the 21st century, the colors in this diagram will get increasingly more red and less blue, meaning that the temperatures are increasing. And if you look up here, that's the global temperature trend over this time period. You can see that there's a really steep increase in temperature, in the global temperature over the last decades. What does that mean for birds? There's been many studies in the last years. They have shown declines across different bird species, across different continents. Here's one example from the Americas, where they showed that since the 1970s, about 30% of the bird populations the bird population in North America has declined about by 30% in this 50-year time span. And there are many studies that link these declines with climate change. And they also show that these bird population declines are disproportionately affecting migratory birds. So migratory birds are undergoing the steepest declines when faced with climate change. If we focus on the Afro-Palearctic migratory system, you can see that there's many species that breed here in Europe and migrate to sub-Saharan Africa. And there's also short distance migrants that breed within Europe and migrate either to Southern Europe or Northern Africa. Christine Howard a few years ago made a nice study showing how the population changes since the 1980s differs between these short distance migrants that stay in Europe for the winter and long distance migrants that go to sub-Saharan Africa. As you can see, the short distance migrants, the population trend over this 35-year period is relatively stable. There's ups and downs, but in the end, the populations are close to where it started in 1980. If you look at the long distance migrants, there's been a steady decline in the population sizes. And that supports this notion that something is going on that affects these specific populations. And that might be climate change. If you look how climate change may affect migration patterns itself, we could see that migration distances might be changing, or wintering or non-breeding sites of the specific populations or specific species might be changing. And here's just a small example for how that might look in the short distance migrants that breed here in Europe, but also winter in the Mediterranean. So if we look at the past data, these populations might be migrating relatively longer distances and wintering in the Mediterranean basin. But then as the climate change sets in, the migration distance shrinks, and so does the wintering sites change. If we look at how this might look for long distance migrants that cross the Sahara during their migration, it might be that at first, these changes are relatively small on the scale of this long distance migration, but then there might be this jump coming when birds are stopping to cross the Sahara and instead wintering in the Mediterranean basin. But this process of course, requires certain adaptations to take place in certain conditions for the wintering birds. I want to go back to a little bit in time, a little bit meaning 200 years ago, when we didn't know so much about bird migration at all. And back in 1822, this stork was found in Germany with the arrow stuck in its neck. And that was the first proof that these storks were migrating to Africa, because the origin of the arrow was traced back to Central Africa. And that's the first time when we learned about white storks migrating to Central Africa. Now, 200 years later, this is how the distribution map of white storks look like. So in blue, we can see the wintering sites here in Africa, quite well mapped throughout the continent. But there are also these green pockets here and there in Europe. And that means that birds are, this green color signifies areas where white storks are found year round. So there are also resident populations nowadays in the Iberian Peninsula, in Spain and Portugal, but also here where I work in Central Europe in Switzerland. And another thing that we have documented quite well for how climate change is affecting migration is migration timing. So here's an example for almost 100 species from breeding in Europe and North America. So how their migration timing has changed over this 70-year period since the middle of the last century. You can see that on average, these species are arriving at their breeding sites about 1 week earlier. And people that did this research could also show that not only that the migration timing is changing, but also the duration of migration is changing, with migration shrinking in when you take the start of migration and end of migration. But all these comparisons to the past and present are possible because there's a reference. So in this study, there's a starting point about in 1955 or 1960 that we can compare this data to. So that requires that at some point people start to document really well what's going on, and then 30, 50, 60 years later, people can compare how the patterns of migration has changed. And about 20 years ago, there was this nice paper by Marcel Visser and Christian Both published calling for establishing a yardstick. So essentially establishing a reference value that we can compare phenology data in the future. And today, I want to argue that we also need a yardstick for where migration routes lie and where wintering sites are of many migratory birds at the moment, because that's a piece of information that we're missing at the moment, I think. So there's quite well information, as I showed you, on these population declines, because people went out and started counting birds, and now they continue to do that, and we can see that the populations have declined. We have very sparse information, though, on migration routes and wintering areas of specific birds or specific populations. There are a few methods that we can use to do that. One that's more than 100 years old now is bird ringing. And it's been an essential part of establishing which species migrate. But it doesn't cover all species, and it doesn't cover all regions equally well. So what we do nowadays, so for the last about 15 years or so, we are tracking birds using small geolocators. So these are devices here that you can see. They record different parameters. So we attach them on the backs of the bird. You can see one here on the house martin, or here one on the starling. So we attach them during the breeding season here in Europe on the birds. They migrate to wherever they go. They come back a year later. We catch the same bird again. We retrieve these devices and we read out the data and see where these birds have migrated to. And these devices are relatively simple. So they are very small. That's why we can attach them to small species. But that also means that they don't transmit data. So they record data on board, and this device needs to be recovered a year later. And what they record is not GPS coordinates, but they record light data. And from this so we use this light data to measure day length and sunrise and sunset times. And we use mathematical models to then establish where the bird had migrated to. Today, I don't want to go into details of how that exactly is done because it's very technical, but I would rather show you a few examples for a couple of species where we have used this method to establish migration routes and wintering sites of certain species where bird ringing have not really captured the full extent of where these species migrate to and which populations go to which places. So let's start with a study on lesser gray shrikes that we did a few years ago. Here you can see a bird distribution range of the lesser gray shrike according to eBird. So red means that this is the breeding areas of this bird. Yellow means passage areas where the birds migrate through, and blue are the wintering areas here down south. And this was a study that was led by my colleague, Joanna Wong. And we set out to use these geolocators that I showed you earlier and tag birds at the breeding sites in Slovakia. And I want to point towards this region here in Central Africa and Chad. If you look here, the birds, when they migrate, they maybe migrate through the very eastern part of Chad. But as I'll show you later, that might not be the case always. That using these geolocators, we might be able to map these migration patterns better and on a population-specific level. So we first collected all the ringing data that's available for these species. And as you can see, there's not a single point here on this map that's extending into wintering ranges or in Africa in general. So all we know is that birds here from Central Africa, they move towards Greece, and that's about it, and then they disappear. This is 100 years or more than 100 years now of bird ringing, but this is all we know for these species. So that might not be the best method how to study it. Instead, we tracked two birds from Slovakian breeding site, and here are the tracks. You can see the autumn migration routes of these two birds in blue. So the birds cross Chad here, one bird very westwards, where eBird data doesn't show any occurrence of these birds. And with the wintering sites of these birds down in South Africa where they're expected. In spring, though, birds don't use the same migration routes. They migrate more eastwards and before returning back to their wintering, to their breeding sites. So what you can see is that what we call a loop migration system, and it's a anti-clockwise loop where the birds autumn migration routes lie west from the spring migration routes, which are further east. So these two maps here show that 100 years of bird ringing gave us very little results for how this particular species migrate, while we did a geolocator study on them lasting 4 years, and we got more information on where specific birds go through the winter and how they get there. And because we use these tags that also record activity data, so this is what we call an actogram, and each line here represents 2 days. So we have a sunrise in white here of day 1, then we have a sunset here, then we have night in between, we have another sunrise of the second day, and then a sunset of the second day. And here it goes from, we tag the bird here up in mid-June, in summer in Europe, and as the year goes by, the bird migrates and then comes back a year later. As you can see here, migration is marked in yellow. So we can see exact timing of each migratory flight. So this bird did a short migratory flight here in middle of July, then was at a stopover site for about a month before continuing its migration again in mid of August. And then again, having a very long stopover here with a very short flight in between before migrating even further. So we can map not only where and when the bird migrated, but we can see exactly how it got there. And as I said, here in the middle, that's a night. So we can also see that these birds migrate exclusively at night, except for maybe a few days of longer flights here at the end of August, which coincide with Sahara crossing. So when they cross Sahara Desert, they extend their flights into the day, trying to cross as far as they can. So that's example one that I wanted to show you about the lesser gray shrike. Then let's jump to tawny pipits. Again, the same map from eBird showing breeding sites in red, passage areas during migration in yellow, and wintering sites in blue. You can see it's a typical species that should migrate to West Africa for winter, and then East Africa and the Middle East on the other side. We tagged birds here in Central Europe using, again, the same geolocators, and we were able to show that these birds from the breeding site here in Central Europe migrate to West Africa. So wintering sites here are marked with the blue crosses. You can see all 6 birds that you have 6 maps here from migrated towards west. If you zoom in on where the wintering sites were specifically, you can see that most birds, except for this one in pink, have 2 dots on the map connected with an arrow. So that means a bird arrived here, for example, spent some period here at one wintering site, and then in middle of the winter moved to another site further south. And most birds moved, or all birds moved, from more eastern sites to more western sites during winter. So that was the first time when we can see where exactly tawny pipits migrate, because again, ringing data for this species have no recoveries at non-breeding sites in Africa. Then a few years later, we repeated the tracking at the same breeding site in Czech Republic, but this time we used the more sophisticated loggers that I showed you also for the lesser gray shrike that also record activity data. So using these more sophisticated tags, we were able to map migration much more precisely, showing that migration routes for these birds go through the Iberian Peninsula before they cross Sahara and arrive at their wintering sites in West Africa. And again, the same actogram that I showed you earlier for the other species, we can see that this bird, for example, so this actogram corresponds to the bird here, showing these 2 maps. So that's its autumn migration here, and that's its spring migration here. And you can see that autumn migration is quite a bit longer, from starting in mid of August, ending in mid-September, whereas spring migration is typically shorter. You can see that the Sahara crossing flight is here end of March, and then it has a longer stopover without flights here at the end of March, beginning of April. That corresponds to this dot here in the map in Morocco. So again, we're able to map these migrations quite sophisticatedly using these geolocators. And because we have this activity data, we can also see how long does it take for birds to migrate. So how many flight hours does it really take to get from the breeding sites to the wintering sites? Here are all 5 birds that we tracked using these geolocators. You can see that they start their migration at different times. So the first bird goes already in middle of August. The last one goes end of August, but the gap is not so large. It's about 2 weeks in between. So they progress here. This is cumulative flight hours that they do on the y-axis. And these dots signify the time when the birds start to cross the Sahara Desert. There's typically a longer stopover without flights before they cross. And then the first bird starts to cross in about, let's say, 10th of September, and the last bird crosses already later in October. So there's a little bit more span between individuals or when compared to the beginning of migration. But if we look at the bird life distribution of this species, we can see that yellow means breeding site, green passage areas, blue non-breeding sites. So you can see that there should be birds also here in central Sahel, which didn't show up in the eBirds map. So what we did now so far is basically we showed that birds from this Central European population go to West Africa. But really we have no clue what's going on with the largest part of the population, which is further east in Europe. And we have no idea where the birds come from that occupy the wintering sites in central and also eastern Sahel. So geolocators are great tools. We managed to, just with a few years of fieldwork, we managed to establish where a certain population migrates, whereas ring recovery data did not provide any information on population-specific wintering sites. But still, more work needs to be done, I think, to document these changes and patterns. Then let's jump to another example, which is the common white-throat. Common because it's all across Europe, common breeding bird here. Again, passage areas in yellow, non-breeding sites here in West Africa in blue, then this Central Africa, and then some birds should migrate also further south. What we did in our study with geolocators, we tagged birds again in Czech Republic, in Central Europe, and we tagged birds in Northern Europe, in Latvia, to track their migration patterns. And common white-throat is actually a species that, in contrast to the previous two examples, have quite a lot of ring recovery data collected over this 100 years of bird ringing. And here, all the ring recoveries that are found at the non-breeding sites of these birds, there's still only 43 of them on this map, but it already kind of shows you the pattern that emerges. So birds from Western Europe migrate to West Africa, birds from Central Europe and Northern Europe migrate to Central Africa, and then birds from further east in the breeding sites also occupy the eastern non-breeding sites. So this is what we call a parallel migration pattern, where birds go basically from north to south, not crossing each other in the middle. And because there's quite a lot of ringing data, what we can do also, we can try to model migration routes of these species. So this is what we did for within Europe, because as I said, for Africa, there's a little bit more than 40 ring recoveries at the Ewing and Suffering combined. But within Europe, there's a lot of ring recoveries that we can use to model migration routes of a certain species by linking different ring recoveries and their locations. So what we found out is that in autumn, there's two quite distinct migration patterns, with some birds migrating to the Iberian Peninsula and then another migration kind of stream going through the Balkans. And here in the central part of the Mediterranean, there's a very little data available from. If we do the same for spring, the situation looks a little bit different. We have a lot of birds crossing the Mediterranean in the middle and very few birds actually migrating to the east, which means that the spring migration routes might be located a little bit more west compared to autumn migration routes. So let's see what the geolocator data shows. So here are the 5 birds that we tagged in Czech Republic, their migration routes, autumn in orange and spring in blue. You can see that it kind of corresponds to what the ring recovery data showed. We have birds migrating from the Central European site to wintering sites in Central Africa, and they all do kind of the same. And for these 3 examples up here, we also see that the autumn migration route lies east from the spring migration route, which is also what this modeling approach showed for ring recovery from the ring recovery data. If we add the 3 birds from a northern site in Latvia, now these are actually 2 birds, but one has 2 tracks here. We can see that they also go to very similar regions than these Czech birds. And if we zoom in on where exactly the wintering sites are, you can see that the Czech birds here in lighter blue are a little bit more northwards compared to the Latvian birds, which concentrate more south. And this is what we call a leapfrog migration pattern. So birds breeding further north in Europe leapfrog their counterparts at the wintering sites, and they actually have a longer migration distance than their southern cousins. And as you can also see, there's circles here and there's squares here, and these are the first non-breeding site and second non-breeding site. So again, similar as tawny pipits, these birds also have each individual has two distinct non-breeding sites. So they arrive in Africa first, spend some time there, and then in the middle of the winter, they move to a different site. And these are kind of the patterns that without geolocator data or without tracking data, we were not able to ever get using the ringing data. There were maybe some indications that birds appear at some part of the non-breeding range and then they disappear, but we never knew where they're going. So now we are able to get some insights into this non-breeding site itinerancy. And then the last example that I want to show today is the Eurasian wryneck. Again, a very common species throughout Europe. The breeding sites here in red span from Spain in the west to I think the limits are even in Japan for this species. So wintering sites in blue, kind of hard to see on this map if we concentrate on the European African migration system. So let's get rid of the rest. So non-breeding sites now in blue. You can see there's non-breeding sites in Spain and Morocco on the western side, and then a little bit around the Mediterranean coast here in the Middle East. But there's not really much going on in either West Africa or East Africa. So this would indicate that this bird is actually a short distance migrant. And we set out to track these birds using geolocators at two sites, one here in Switzerland where I'm based, and another one a bit further north in Germany. And if you look at the BirdLife species distribution lanes, it's quite different from the map that eBird shows. So it shows that the main non-breeding sites are here in Africa throughout from west to east, but there's also the pockets of birds wintering here in Spain and Portugal and also in North Africa. So it's not the same pattern that we can see in eBird data and if you look at the BirdLife distribution maps. So about more than 10 years now ago, there was a PhD student, Trien van Fijk here, who tracked wrynecks from Switzerland, and he found that he managed to track 6 birds using geolocators, and he found that all the birds were short distance migrants. So 5 of them wintered here in Spain and Portugal, 1 in Morocco. But there was no indication that there's any bird crossing Sahara Desert. So some years later, we set out to another tracking campaign in Germany, a bit further north, in hope that we find these first long distance migrants. This is the data from the newer tracking study. There's 2 sites here in Germany where we tagged the birds. And again, there's 5 birds here on this map, all short distance migrants. But we also had 2 birds, what we called medium distance migrants, so birds wintering in North Africa. And finally, we also found this long distance migration that we expected in this population, but it's only 2 birds out of 9 that we tracked that actually crossed the Sahara Desert and winter in West Africa. If we look at the migration distance comparatively between these short distance migrants here in blue, these medium distance migrants in the middle map in orange, and long distance migrants in red, you can see that the migration distance is quite a bit longer. It's twice as long for the long distance migrants compared to the short distance migrants. But I want to point you in a direction a bit differently. I want to point towards the fact that from the same breeding site, we have short distance migrants wintering in Iberian Peninsula. We have these medium distance migrants wintering in North Africa, and we have long distance migrants crossing Sahara Desert. So there's already a lot of variation going on in this population. And to make a loop to what I show you at the very beginning of the talk is that this pattern, basically we have these long distance migrants that are crossing Sahara and with expected wintering sites here, but it seems like the birds on these 2 maps, they have made this jump across Sahara, meaning that they don't cross the desert anymore, and they have shortened their migration distance and winter at in the Mediterranean basin. So, as I say, as I said earlier in this talk, I think what we need is to establish a yardstick really for where the changes in migration patterns are happening. Because I think if this example of all Swiss wrynecks being short distance migrants, and if we go further north in the continent and these German birds having a mixed strategies, I'm not so sure that if we did this study 20 years from now in the future, we would find any long distance migrants in that German population. So things are changing very rapidly. And if I look from a purely European perspective, I think we have these yardsticks established for population changes. I showed you the population declines over in North America earlier and in Europe. So they're monitoring programs going on now in both continents that we can track the changes in population sizes. Phenological changes, I think we're also doing a really good job because there's a lot of citizen science data that we can use for phenological measures, like arrival of migratory birds in spring or departure of migratory birds in autumn. And a lot of countries also have their breeding atlases that map breeding range shifts. And a few years ago, there was also a European breeding atlas #2 published, so we can always compare. We have a reference data, which is the breeding bird atlas #1, and then we can compare it to how the distribution patterns have changed between different atlases. Where I think we're still not doing a very good job is mapping non-breeding areas and mapping migration routes. And these examples that I showed you today are just a part of what we've been doing here in Switzerland with tracking work over the last 15 years. We've been trying to go out for populations that have not been tracked or where we know little information based on ringing recovery data, and try to get this reference data that we can use in the future when we think about climate change and how that has affected migratory patterns of birds. We tried to summarize this a few years ago for what's been done with geolocator tracking across Europe. So back then, so this is already a 5-year-old study, there were more than 20 species that we included here in this study, showed where in Africa their non-breeding sites are distributed and relative to where they breed in Europe and which flyways they use. I think, however, there are a few promising signs in this mapping non-breeding areas, for example. So eBird is a great source of data, and I think the more we report bird observations on it in winter, the better the maps will be. You see that still these eBird maps, and if we compare them to the BirdLife species distribution maps, they don't always match because there's a lack of data from certain areas. And another great initiative for migration mapping, I think, is the Eurasian African Bird Migration Atlas. If you haven't been to this website, I highly recommend you go there. There's migration ring recovery data from more than 300 species. But again, species like the lesser gray shrike and the tawny pipit that I showed you earlier are not on this list of 300 species because there's just not enough ring recovery data to map anything yet. So this tracking work that we've been doing is, I think it's quite essential for certain species to see how migration patterns are changing if we want to reference that in the future. And that's it from me today. And I want to thank all the people here listed that participated in the particular studies that I showed you today, but there's a bunch of people involved in the field and all across the continent, both in Europe and Africa, that are doing brilliant field work in trying to map this data. I think it's hard data to gather, but we're just at the beginning to really establish a proper yardstick for both migration routes and wintering sites. So thank you.
Merci. Donc bonjour à tous. Je vais faire un rapide résumé de la présentation. Donc notre invité, c'était Martine Briedis de l'Institut ornithologique suisse, et donc qui nous a présenté les études qui sont faites par l'Institut concernant les routes migratoires des oiseaux, donc entre l'Europe et l'Afrique, donc les espèces qui vont se reproduire en Europe et hiverner en Afrique. Et donc la problématique principale, c'était euh, finalement d'essayer de comprendre comment le changement climatique pourrait impacter dans le futur la migration de ces oiseaux, notamment les espèces qui migrent sur de longues distances. Et donc, pour comprendre tout ça, l'un des enjeux, c'est de savoir plus précisément, d'avoir plus de données sur exactement quelles sont les routes qu'empruntent les oiseaux, leur timing en termes de migration et aussi les sites d'hivernage en Afrique, puisqu'on manque encore de données sur beaucoup d'espèces, sur les zones exactes où ils vont passer donc leur période de non-reproduction. Et donc, il y a différentes techniques pour obtenir ces données. Une des techniques utilisées, c'est ce qu'on appelle ring recovery. C'est une fois qu'on a des oiseaux qui ont été bagués en Europe, l'objectif, ça va être d'essayer de retrouver ces oiseaux bagués en Afrique pour savoir bah, voilà, où est-ce qu'ils ont été, pouvoir savoir où est-ce qu'ils vont exactement. Et sinon, donc une autre technologie qui peut être mise en place, c'est d'utiliser des trackers qu'on va mettre sur l'oiseau. Et donc, ces trackers vont enregistrer les données, notamment les données jour-nuit, qui vont permettre, après, avec des logiciels, de pouvoir savoir où exactement l'oiseau est allé, combien de temps il a mis pour aller à sa destination et bah, quelle route il a emprunté pour atteindre sa destination. Et donc, durant sa présentation, il nous a montré un exemple de ces données récupérées via ces trackers géolocalisateurs sur la pigrèche à poitrine rose, le pipite mousseline et, euh, et la fauvette grise. Et donc, grâce à ces exemples, il a pu enfin, ils ont pu mettre en évidence donc, exactement où ces oiseaux allaient, avec quelques individus. Et ce qui était intéressant, si par exemple, on prend bah, le dernier exemple avec... alors, attendez. On perd pas. Ah oui, et aussi, il y avait une quatrième espèce, le troccol fourmilier, désolé. Et donc, pour prendre un exemple avec une des espèces, le troccol fourmilier, eh ben, ils se sont aperçus que, donc, ils ont mis des trackers sur certains individus en Suisse et aussi en Allemagne, et ils ont pu observer que, bah, sur cette population d'Europe centrale, certains oiseaux étaient des migrateurs sur de courtes distances, donc qui s'arrêtaient en Allemagne et en Espagne. Certains allaient jusqu'au Maroc et quelques-uns venant d'Allemagne donc ont été des migrateurs de longue distance qui ont traversé le Sahara. Et donc là, ce qui est intéressant, c'est qu'on voit que sur finalement une même population d'Europe centrale, certains oiseaux peuvent être des migrateurs longs et d'autres peuvent être des migrateurs courts. Et donc là, ce qui serait intéressant, c'est de voir dans le futur si les migrateurs qui traversent le Sahara vont finalement, à cause notamment du changement climatique, changer leur stratégie et ne plus faire ces migrations de longue distance. Donc pour pouvoir continuer un petit peu à mieux comprendre les patterns de migration, notamment dans le futur et au vu des changements à cause du changement climatique, il y a un besoin important bah, d'engranger des données et donc bah, d'essayer d'avoir beaucoup plus d'individus marqués, surtout du côté africain, d'avoir une meilleure capacité pour recapturer par exemple les oiseaux, les localiser sur leur site d'hivernage.